Okay, so here we've got a piecewise defined function. So we've got when if x is less or equal to -1, we use this definition. If x is greater than -1, we use this definition. What we do is asked to evaluate a couple of different things, right? So f of -2, right? -2 is less than -1. So we're going to use the first definition. And then we'll put -2 in for x in 1 minus x, and we get 3. F of -1, so -1 is it's equal to -1, so we're still using the first definition. F of -1 is 1 minus -1, which is 2. F of 0, right? 0 is greater than -1, right? So we're using the second definition. 0 squared, which is 0. So if I want to sketch this graph, right? Let's put some axes down. Start by putting in the points we just found. $50 in, right? -1. Right, and now let's think about how we're going to sketch the whole thing. Right, so we've got 2 bits here. What you want to do is just sketch for 2 different functions. Forget about the domain restrictions for a start, right? So let's sketch 1 minus x. Right, we've got 2 points to go through 1 minus x already, so 1 minus x looks like it looks like that. Right? And x squared. Let's have a few more points here. So -1 squared is 1, -2 squared is 4, 1 squared is 1, 2 squared is... Right, this is a parabola that looks not like that. Let's try to be a little neater. Like that. Right, now let's go back and think about where our domain is actually defined, right? The linear is defined on the -1 bit, so right, our linear is defined on this bit. Our quadratic is defined on this bit. Right, so let's just get rid of highlighting. From -1. Alright, -1 left, that's our linear function. Get rid of this pencil mark. Right. Now our quadratic from -1 onwards. We have that. So again, let's just get rid of some of these pencil marks that we don't want. So we've essentially graphed, I think, the only thing we need to do is specify clearly what's happening at -1. So if you look here, right, when x is exactly equal to -1, we are on the linear function, and we denote that with this closed dot here. Right? And what that's saying here is that when we get close to -1, we get close to this dot, and when we hit -1, we're actually on 2, y equals 2. whereas we have an open dot on the quadrant because we have a discontinuity in a function. And that open dot indicates that as we get close to -1 from above, we get close to y equals 1, but we never actually get there, right? We don't get to exactly x equals -1, y equals 1. So when you go to exactly there, you jump up to the other, to the closed dot. Oh, didn't know that. So, what's left, we should probably do a little bit of labeling here. This is f of x. Right. There we go. We have sketched a graph of this piecewise defined function.